Hi class. In this video, we're going to talk about sampling procedures. At the beginning of this semester, we talked about population. A population is the entire collection of individuals that you are interested in studying some of their characteristics. The population of interest, or the so-called target population, can be small or large. When the population is very small, you may want to consider skipping the sampling process and collecting data from all in the population. A critical issue about defining the target population is accessibility. For example, in my case study of college student retention, my population of interest is all full-time students attending four-year colleges or universities in the US. But I don't have access to this population. So it would be more realistic to define my target population as all full-time students attending the University of Memphis. In some studies, there can be more than one target population, and the sampling process may vary for different populations. In most research projects, it's unlikely that the researchers have access to the entire population, or it's unlikely that time and resources are available to collect data from the entire population. Therefore, sampling is an important step in which a subgroup is selected from the target population. Put in a different way, a sample is a subgroup of the population. The process through which we choose a sample from the population is called sampling. In situations where the target population is not accessible, another concept comes into play that connects the target population and the sample. This concept is called the sampling frame. Go back to my case study example. I don't have access to all full-time students attending four-year colleges or universities in the US. So as a stepstone, I could define a sampling frame, which is all full-time students attending the University of Memphis. We actually want the sampling frame to be identical with the target population. Unfortunately, it's often not the case. That is why sampling frame as a concept has to be introduced. Just to be clear, my target population is all full-time students attending four-year colleges or universities in the US. My sampling frame is all full-time students attending the University of Memphis. The campus OIR office randomly chooses 3,000 students from roughly 20,000 full-time students and provide me their emails. This list of 3,000 students is my sample. A sample is a collection of subjects that we have access to and can collect data from. We collect data from the sample and use the sample data to make inferences about the characteristic of the population. This is called generalization. In order to make the generalization possible, we want the sampling procedures to be unbiased so that the sample is representative of the target population with respect to the characteristics that we are interested in studying. There are many different sampling procedures. They are divided into two categories. The first category is called probability sampling. Probability sampling procedures are attractive because the resulting samples can be unbiased and are more likely to be representative of the populations. The second category is non-probability sampling. All non-probability sampling procedures share the same problem. That is, they produce samples that are much more biased than those of the probability samplings. Non-probability samples are not representative of the population, and the results of studies using non-probability samples should not be generalized to the target population. Let's talk about non-probability sampling procedures first, simply because they are used more often than probability sampling, and you see them a lot in published studies. All non-probability sampling approaches have one thing in common. Members of the population have an unequal chance of being selected. The first non-probability sampling procedure is volunteer sample. To get a volunteer sample, you first let people know about your study. You choose those who volunteer to participate as your sample. You may offer some sort of incentives, but the key point here is that people who join your research are volunteers, and in some known or unknown ways, they are different from those who did not volunteer. For example, the first 10 people who called a radio station to answer 3 questions about unemployment on a Thursday morning would be very different from those who were in the population but did not call. The second non-probability option is called convenient sample. For example, I'm teaching in the College of Education, and if I need to collect data, I may go to some of our undergraduate classes and ask the students to complete my survey. I could offer them course credits. So I got my samples through some sorts of convenient access. Convenient sampling is also called haphazard sampling. As you can tell, researchers use a sample simply because it's convenient to access. In some studies, the researcher used so-called quota sampling. The key here is that the sample is matched with the population based on certain makeup measures. For example, if we have 60% female students in the population of the university, I want to take a sample in which there are 60% females as well. Even though the gender makeup is comparable between my sample and the population, still is considered a non-probability sample because the male and female students in the sample tend to consist of people who are either conveniently accessible or volunteers. Another non-probability procedure is the sampling of typical people from the population. This can be done when the researchers have in mind some key characteristics they are interested in studying. So they try to choose people from the population who seem to be typical on those key characteristics. The example I gave you here is about research on gun control. If the researchers believe that people's income and educational levels are the 2 characteristics that relate to their attitudes towards gun control, they would select a sample of participants who have income around the median range and use high school diploma as the average educational level. The problem with this approach is that those typical people may fail to represent the attitude of sizable groups in different sections of the population. The last non-probability sampling procedure we're going to discuss is called the purposive sample. Researchers purposefully choose respondents whom they believe could be more informative about the topics they're interested in to be part of their sample. For example, a researcher interviewed principals of Shelby County schools about educational reform. The success of studies using purposive sampling depends on how carefully the researchers select the sample. Ironically, in most cases, researchers do not have evidence to show that they have sampled appropriately. Now, let's move on to probability sampling. Probability sampling is based on the principles of randomization, and it generates samples that are less biased and better representative of the population. The key difference between probability sampling and non-probability sampling is that in probability sampling, individuals in the population have a known probability of being selected. For non-probability sampling, this knowledge is not available. Having a known probability of being selected allows some statistical manipulation so that more accurate inferences can be made about the population based on the sampling probability. The best and the simplest probability sampling procedure is called simple random sampling. A simple random sampling procedure starts with a list of all individuals in the population. Then some mechanism is used to randomly select a sample from the population. It's the best and simplest sampling approach to generate a non-biased and representative sample of the population. So why don't we see this used that often in research studies? Well, the biggest problem is that it's very unlikely that we have access to a complete list of all individuals in the population. So random sampling is good, but impractical. Next on the list is the systematic selection procedure. It also requires a list of all people in the population. The sample is selected by arranging a list of people in random order. Then a random number is generated as a seed, and the sample is chosen based on this random number. For example, if I need a sample of 400 students to study drinking behaviors of undergraduate students at the University of Memphis, the total population size is 20,000. Knowing that 400 divided by 20,000 gives 50, I pick the first student using a random number between 1 and 50. Let's assume that the random number is 24. Then my sample will consist of students who are number 24, number 74, number 124, number 174, so on and so forth, all the way to 19,974. So the final sample consists of every 50th individual on the list, starting from the random number seed. It's a convenient variation of simple random sampling, but still, it's very unlikely that we have access to a complete list of all individuals in the population. The next probability sampling procedure is stratification sampling. This procedure is used a lot more for studies at the national scale. In this procedure, researchers divide the entire population into small, much more manageable chunks, and then take a random sample from each of the chunks. The major advantage of using stratification sampling is to increase the accuracy when there are great variations in the target population in terms of the population characteristics being studied. But the major challenge is that the information needs to be available for all population members on the variables used to make the stratification. One special way to use stratification sampling is to increase the representation of minority groups in the sample. For example, knowing that racial minorities are underrepresented in STEM majors, I could divide up the population into chunks by race and increase the probability of being selected for people in minority groups, such that the probability of being selected is 5% for whites, 15% for blacks, and 50% for Native Americans. Of course, I need to have race information of the population in order to use this sampling procedure. The probability sampling procedures we have talked about so far use randomization at the individual level. In other words, individual subjects are randomly selected from the population. Cluster sampling is different because naturally existing groups of people called clusters are randomly selected from the population. For instance, if a school district wants to survey students' technology use and academic performance, they could randomly identify one fifth grade class from each of the 12 elementary schools and collect data from all students in the selected classes. Randomization happens at the cluster level, so this approach is cost effective, but as a trade-off, the accuracy is not as good as the first three procedures. The last probability sampling procedure I want to mention here is multi-stage area sampling. We don't see this procedure used a lot because it's mostly used for sampling a set of geographic regions in large-scale surveys at the national level or state level. For example, the selection may begin with 5 randomly selected states. Within each state, 3 randomly selected counties. Within each county, 10 randomly selected neighborhoods. And within each neighborhood, 5 randomly selected households. The stages are state, county, neighborhood, and household, and randomization takes place at each stage. We have introduced quite a few sampling procedures. Which one to choose depends on many factors. How large is the target population? How large does the sample need to be? Also, accessibility to the population and the available time and financial resources. The ultimate goal of sampling is to improve accuracy. In other words, the sample should be representative of the population as much as possible. Also, keep in mind, the larger the sample size, the better. Larger sample sizes not only improve the accuracy, but also contribute to greater statistical power of the data analysis at later stage. Be clear that you can combine different sampling approaches. You can also mix up probability sampling with non-probability sampling. The key is to be flexible and creative. Do what you can to improve the resemblance between your sample and the target population. It's time to highlight some special considerations. If you need to work with a special population of an extremely small size, try all you can to get access to more members in that population. Ask members to spread the word in the community, and you can recruit more through snowball sampling. On a different note, no matter what sampling procedures you use, be mindful not to make certain common mistakes. One common mistake is that some sections of the population are overlooked in the sampling process. For instance, if an online survey was distributed to high school students about home internet availability during the pandemic, those without internet access could be left out. A second common mistake is that a wrong population is sampled. For example, if the research goal is to study whether the admission fee is too high for a city pool, and the researcher only asked the swimmers inside the pool to be in the sample, apparently those who could not afford the cost were left out of the study. So this is a typical example of the wrong population being sampled. The last point of today's discussion is about refusal or non-response cases. Non-response is a common problem in all kinds of survey studies, but it's especially severe for online surveys. Even if you started with a probability sample that was intended to represent the population, when the refusal or non-response rate is high, the actual sample you end up with would not be representative of the population because those who completed the survey were self-selected to participate in the study. You can gather information to see whether the refusals are concentrated among certain groups. My opinion is that it is important to use sampling procedures to improve accuracy. Nonetheless, in 99% of all studies, the final samples are not representative of the population. Rather than claiming generalizability, it's better to emphasize that the same study needs to be replicated with different sections of the population to verify whether the findings of a study are generalizable.